Hi everyone, let's talk about surface area of cylinders. So first we need to think about what the net of a cylinder would look like so we can see all of the parts of it. If you were to take a cylinder and cut it and flatten it out, you're going to see the two circles that are on the top and the bottom, but the middle part of the cylinder is going to turn into a rectangle. So we have a rectangle that represents that middle part, and then the top and the bottom circles, to make the net, we just need to connect them, one on top and one on the bottom. It doesn't matter if you put it in the center or the left or right, as long as you have one on the bottom and one on the top and connect those. If you want to find the surface area, one option is just to find the area of these three parts. So you find the area of the two circles, that's pretty easy, pi r squared. And then the rectangle, we need to think about how we would find the length and width of those parts. Well, this part of the rectangle, that's just the height of the cylinder. But this part of the rectangle is going to be represented by the circumference of the circle. Now think about that. If you roll up that rectangle, it's going to be the exact length as the circle that's on the top and the bottom. So this is just the circumference. So option one is to just find the area of the rectangle and then add that to the area of the two circles. Option two is using the formula. So this is exactly what's on your formula sheet. You've got the lateral area formula, which is again is just the rectangle really. So 2 pi RH represents the rectangle because 2 pi r is their circumference and then h is the height of the rectangle. The surface area here is the 2 pi r squared, that's your two circles, plus the 2 pi RH, which represents the rectangle. So you can find the area of each part and add them up in option one or use your formula in option two. Okay, so let's try out this problem. We're going to find the surface area of this cylinder, and we'll start by drawing out our net. So just like last time, we're going to have a rectangle and our two circles. And for the rectangle, the height of our rectangle, or this dimension here, that's going to be 16. And this part will be the circumference of our circle. Well, the circumference of our circle, the radius is 5. So pi times diameter, pi times 10, will be 10 pi. So the rectangle is 10 pi by 16. And then, of course, our circle has a radius of 5. All right, so this next part here on the right, I actually meant to take this off, but it's here, so let's just try it. This is just a way to think about what a shape looks like from each view. So if you're standing like right in front of a cylinder, right in front of this cylinder and looking straight at it, what you're actually going to see is going to look like a rectangle. If you were just like right in front of it, not to the side, not looking like above it or below it, but just directly at the front of it, you're going to see a rectangle. If you were looking at it from the top, you would just see a circle. If you were looking straight down, like a bird up in the sky, looking straight down at you, would just see a circle. And then if you were on the left or the right, for this shape, it's just going to look like a rectangle. Again, it's going to look exactly the same from the front, the left, or the right. Okay, so now we're going to find the surface area by finding each shape, and then we'll do the surface area with the formula. But for each shape, let's make sure we're finding the area of each part. So we're going to start with the rectangle. Well, area of a rectangle is length times width. And for this rectangle, we have 10 pi times 16. So that's going to be 160 pi. All right, for the circle, we have pi r squared. And our radius is 5, so it's going to be 25 pi. And then don't forget that there's 2, so now we have 50 pi. Okay, so to add all this together, add the circles with the rectangles, 160 pi plus 50 pi, and we get 210 pi. And this would be kilometers squared. Wow, that's a really big cylinder. Okay, now let's try it with the formula. Okay, so with the formula, our formula says that the surface area is equal to 2 pi r squared plus 2 pi r h. All right, let's fill in. Our radius is 5, so 2 pi times 5 squared plus 2 pi times 5 times 16. So we get 25 times 2, that's 50 pi, plus 2 times 5 is 10, and 10 times 16 is 160 pi. These numbers should look familiar, just like the previous one. And when we add them together, we get 210 pi kilometers squared. Okay, let's talk about surface area of pyramids. So first, just recall that every pyramid has one base. The base could be any polygon. It can be a square, a triangle, a hexagon, an octagon. Anything can be the base. Then the sides of the pyramid is made up of triangles, the number of triangles equal to the number of sides in the base. All right, let's look at this box over here. Since there are essentially two heights in a pyramid, one of those heights is for the triangles themselves, like the height of each triangle, and then the other height is the actual height of the pyramid. So notice how this is showing you the height of the pyramid, right? Kind of straight up and down the center of the pyramid. And then over here we have the height of the triangles. Those heights could be referred to as the slant height of the pyramid. It's sort of the slanted height on the side. It's also called the lateral height of the pyramid. It's also called just the height of the triangle. So we call that letter L. I should put that in L right here. So the H is for the height of the pyramid, and an L is for the slant height, or this height of the triangles. When you look at those two lengths, you can see that the slant height, the L, is always bigger than the height of the pyramid, all because of a right triangle that is sort of formed if you look down the center of the pyramid out and up. I did not highlight that very well. Let's try that again. If you come down the center of the pyramid and then across to that slant height, that right triangle shows that the slant height is really the hypotenuse of that triangle, and that is always going to be bigger than the actual height of the pyramid itself. Okay, so the other way you can think about the height of a pyramid is that it's the perpendicular distance between the base and that top point. The height is perpendicular to the base, where the slant height is slanted. It's at an angle. All right, let's go ahead and draw the net of a pyramid, and we'll do of a square pyramid of what we're seeing over here. So we're going to start with a square in the center. That is a really bad square. Let's try that again. Here we go. So here is my square, and then we're going to have a triangle coming out from each of those sides of my square. So one option to finding the surface area of that is to just find the area of each piece, right? Find the area of each of the triangles and then add that to the area of the square in the center. The second option is to use a formula. So let's just look through our formulas and make sure we understand all the letters now. So we know LA stands for the lateral area. That's really just the triangles. It's finding the area of all the triangles. And the formula is 1/2 LP, where P stands for the perimeter of the base. We saw that earlier. P is the perimeter of the base. L is the slant height of each triangle, which is really just the height of each triangle. The second part of the formula, our second option, is a surface area formula, which is 1/2 LP plus capital B. Again, capital B stands for the area of the base. So we're just adding in that extra piece because we're adding in the actual area of the base. That's your normal surface area formula. Just sometimes we don't want the base and we just call it the lateral area. All right, so let's try it out. So we're going to find the surface area of a square pyramid that has a slant height of 20 and has the sides of the square, the sides of the base, have the length of 8. So we can just sort of use this diagram here to label that. The square on the bottom is going to be an 8 by 8 square. And then the slant height, this L going along the side of the triangle here, that's going to be 20. All right, let's first do it by finding each piece. So I'm just going to draw a quick net again so we can see our pieces and we can label them. If you have room, that would be great if you could draw it too. So for the square, again, this was 8 by 8. And then for the triangles, we know that the height of the triangle is really the slant height. And so that is going to be 20. Okay, so to find the surface area of each piece, let's start with the square. And you can just use length times width, or you could even just use sides squared. They both are going to work for a square. So in this case, we've got 8 squared, or 8 times 8, which is 64. All right, next we need to find the area of the triangles. So area formula for a triangle is 1/2 base times height, which is 1/2 times 8 times 20. So 1/2 of 8 is 4. 4 times 20 is 80. And then don't forget we have 4 of them. So times 4, and our total is 320 for all 4 triangles. So we need to add up 64 and 320. And we get 384 square inches. All right, now let's try the formula. So the formula says 1/2 LP plus capital B. So L, again, is our slant height, and that is 20. P is the perimeter of the base. Remember, the base was a square, and it's 8 inches on each side. So the perimeter of the base would be 8 times 4, which is 32. And then the area of the base would be 8 times 8, which is 64. All right, let's continue on with our formula. 1/2 of 20 is 10, and 10 times 32 is 320. And we want to add 64 to that. And our final answer is 384, just like last time. Okay, our final section here is surface area of cones. Remember that a cone just has one base, and that's a circle. And the only way to find the surface area of a cone is to use a formula. So the lateral area, which just means not including the circle, is pi RL. Pi times r, which is the radius, times L, which is that slant height of your cone. Pi RL is going to give you the outside of the cone. And then for the regular surface area, which includes the base, we're just going to add in the pi r squared, which is the circle on the bottom. So pi RL is the outside of that cone plus pi r squared, which is the circle. All right, so let's just do an example. The first one says to find the surface area of a cone with radius of 3 and a lateral height of 10. Let's write down our formula. Surface area equals pi r squared plus pi RL. Our radius is 3. So pi times 3 squared plus pi times 3 times the lateral height, which is 10. So we get 9 pi plus 30 pi, and that's going to equal 39 pi, in this case centimeters squared. Pretty simple. Our next example has us just finding the lateral area. So the lateral area formula is just pi RL. We don't need the plus pi r squared because we're not finding the area of the circle. So imagine you have an ice cream cone and you're going to dip it in chocolate. We want to figure out how much is going to cover the outside of that cone. We don't want to cover across the top, and we can't put any ice cream inside. So pi RL is just going to be pi times the radius, which is 8, times the lateral height. Oh, we don't have it in this one. So look at this diagram. We were given the height of the cone, which is 15, but we need to find the lateral height of our cone. And we can use the Pythagorean theorem to do that. So we've got 8 squared plus 15 squared is going to equal the lateral height. I'll just call it c squared. 8 squared is 64. 15 squared is 225. We add that together, and we get 289, and therefore it's 17. Some of you might recognize that as a Pythagorean triple. 8, 15, 17 is one of those. If you knew that without having to do any work, you can use that. All right, so the lateral height is 17, so we go back to our formula. It was pi times the radius of 8 times the lateral height of 17. So 8 times 17, well, 8 times 10 is 80, and 8 times 7 is 56. So that's 136 pi, and this is in inches squared. That's the lateral area of our cone. All right, our final question is to find the surface area of this figure, and it's a combined figure. We often call these composite figures or composite shapes, and we have a cone stacked on top of a cylinder. So we want to find the lateral area of that cone, but without a circle underneath it. There's this part of the circle isn't something that we need to find the area of. And then we need to find the cylinder, but the cylinder does have a bottom to it. So however you want to look at that, you could either think of it as a full cone with a bottom plus just the lateral area of the cylinder, or it's the lateral area of the cone plus a cylinder with just one circle. Well, it doesn't have both bases, it only has one of them. I think this is going to be easier to do a full cone surface area plus the cylinder without the circles, which means the cylinder lateral area. I hope that makes sense. So there's basically one circle that we need to find the area of, surface area of, and that's on the bottom, but we can think of that within the cone's formula. That to me makes sense, is the easiest. I hope that makes sense to you. Now, in order to find the area of our cone, we need the lateral height of our cone, and we don't have that right now. So at the bottom, we can see that 20 is the diameter of our circle, and that means that the radius is just 10. So if we draw that in up here, just to see where that radius would be, that radius is going to be 10. But what we don't have is this lateral height along the side of our triangle. So remember, we can think about this triangle drawn in right here. I'm going to redraw that so you can just see what I'm talking about. That triangle, the bottom is 10. And then because of this, we can see this side is 10. So it's really an isosceles right triangle, which means the slant height, we can use our shortcut, and it's 10 radical 2. So the L value, that L, the slant height of our cone, is 10 radical 2. Okay, let's see if we can go ahead and jump in and use our formula. So to find the surface area of our cone, it was going to be pi RL, that's the slanty part of the cone, plus pi r squared. All right, let's do that part. So pi times the radius, which was 10, times the slant height, which is 10 radical 2, plus pi times again the radius, which was 10 squared. Let's simplify that. On the left here, 10 times 10 is 100 pi radical 2 plus 100 pi. Now I can't add those together because one of them has the radical 2 inside of it and one of them doesn't. So that's as far as I can go for the cone surface area. Now let's do the cylinder, just the lateral area. So you can consult your formula sheet if you want to, or maybe you remember, but the lateral area for the cone, or for the cylinder, the lateral area for the cylinder is really just that rectangle. And that was just 2 pi RH. Remember, 2 pi r is like the circumference, and then the height is the side of the rectangle. So we have 2 pi times the radius, which is 10, times the height of that rectangle, which is really the height of the cylinder, so that's 60. All right, so 2 times 10 is 20. 20 times 60 is 1200 pi. And that's the cylinder. So now we need to add this together. We've got the cone plus the cylinder. So we're trying to add together this and this. And we can add the two parts that both have just the pi. So we can add 100 pi with 1200 pi. So I'm going to write my final answer up here where I've got a little bit of space. So 100 pi plus 1200 pi, that's 1300 pi. And then plus 100 pi radical 2. And that's going to be inches squared. Again, sometimes you're just going to have to type all that in the calculator and get a decimal, but I like you to see how to do it the exact way because it's a little harder that way, and I just want to make sure you understand what you can add together and what you can't.